that, folks. Can you all hear me better? Alright, can you all hear me now? Awesome. So I just basically said hi to all of y'all. And I can see so many hellos. Sunday morning, y'all are up here learning something new. That is amazing. So, how was day 6? How has day 6 been till now? How was day 5? Is it too loud now? Is that so? Hi there, boy. Alright, folks. How was day 5 and how's day 6 coming along? Do you have your favorite streams yet? Do you have any new favorite emulators yet? I'm guessing it's Sunday morning. I don't expect you all to be in a very enthusiastic state. It was. I'm so glad it was. I definitely plan on joining your stream soon. I know, right? That's every GHW. That is every GHW. Especially because, for us, when we're streaming, we're constantly preparing for the next content. And yeah, you never know where the time goes. But awesome. So, I don't see a lot in the chat. There aren't many questions. I'm going to quickly send you all the check-in link in the chat so that you all can get your points and don't miss out on any extra swag that comes your way. Alright, folks, in case you all aren't aware, please register and check in to get those extra points to get your swag upgrades that happens every quota of points. And you all had a lot of questions last time about how to submit challenges. So if you all want me to quickly go over dev post or the GHW website, let me know. I'm happy to walk you through all the procedures. And yeah, let's dive right in. Streaming databases is something I've started looking into recently myself. I'll show you a couple of examples of running this particular database that I've been looking into. And I'm fairly new to the topic, so if you ask me a question I don't know, we'll be looking at the answers together. So that should be fun. Alright, folks, let me share my screen and my PPT. So you all know this entire GHW, I've done a PPT that is more of a flashcards for me than actually information, and that's how it's gonna be. I'm sorry, I'm searching for my PPT. Window. There we go. Right, folks. Alright, so let's get started. What are we answering today? Well, okay, I think I have. Yep, right. So we'll do a quick introduction. Hi, Susmita. I see you joining in for after a long time. So Susmita here is one of the regular hackers who has her own YouTube channel and does a lot of things for the community. Y'all should definitely go say hi to her. But yeah, folks, we'll do a quick introduction in case y'all are joining a GHW stream for the first time. We'll go into what's a streaming database. We look into why do you need a streaming database. Then we look into, how do you choose a streaming database, especially if you're using it for IoT, because obviously, why would I talk about anything but IoT? And then I will look into how can we practice. So basically, I just show you a couple of ways to kind of get your first streaming database up and running, how connections work, how materialized views work, and there's something called the cloud version of the streaming database that I plan to show you all. So I'll show you the cloud version. I would have loved to do an hands-on, but the local version, I haven't been able to get it up and running in time. And the cloud version, you all will have to request access. So there's a chance you might get access to the cloud immediately or in a couple of days. If you get it in a couple of days, it's a simple procedure. It'll take me like 5 to 6 minutes to, do a couple of clicks, get it up and running. So y'all can follow that whenever y'all get time. Yeah. Oh, so yeah, I'll talk about, how, so every time I've done an IoT project, especially for a hackathon, an IoT project running alone, is pretty useless, right? You need to have some form of a dashboard, you need to have some form of, integration with your entire project. So the project is usually that, the projects that I ended up doing were, okay, IoT data. There's a lot of algorithm on the controller, of course, but then there's also happening a lot on the software end. So we'll have a dashboard, there'll be calls going out from there. We had once a video calling application set with a IoT trigger. So how do you get these things connected, right? Uh, I always used an RTDB, that's real-time database, which is basically a streaming database. I do love Firebase for its ease of IoT connection, but I have been kind of branching out lately. While I haven't gotten a successful prototype up just yet, this is definitely something that I find intriguing. Uh, yeah, so y'all should always, if you're looking into trying a database for IoT, definitely give Firebase a try because it's got some very well established libraries. So y'all basically have to put in zero effort to get it up and running. Hi, welcome to the stream. All right, let's get started. Hi, folks. I'm Ritvi. In case you all are joining the stream for the first time, I complete almost 2 years as a coach in a month, and I'm super excited about that. I identify as a maker, so that's something I can talk about endlessly. I'm currently freelancing with a couple of different companies in different ways. You all did ask me if I was into IoT. Well, yes, IoT freelancing is difficult because it's almost in person. I am doing freelancing more towards DevRel. Hit me up if you want to know more, right? Hi, Neutron. Welcome to the stream. I see so many new folks joining in today. I usually know like the 6 people who will be replying in the chat. So, so yes, there is an entire slide dedicated to SQL real-time streaming. But again, I'm not a backend person. This is just me exploring this as an avenue. So if you ask me a good question, we'll look it up together. That is a great question. We'll get to it when I get to explaining streaming databases because you all answered the first question, remember? Uh, we're not building anything today, Susmita. It's a very, very, discussion-based thing. I'll show you how to get started. I'll show you 3 ways of doing it yourself. Y'all don't have to follow me. It's gonna be a while. See, the thing is, the things that I'll show you either require Docker, so you'll have to install Docker and get it up running, or you'll have to request for the cloud access, which is currently in the beta mode. So nothing y'all can follow real time. But again, y'all can always come back and tune in later. I do not understand this question. What kinds of makers are there? Do you all have like a proper list and tags? Alright, folks, let's move on. Okay, time for a real live exercise. You all know we do this because we are live and it's a great opportunity for you all to, interact with each other and, show some engagement. So, here's the nice question. This time we don't have to post it in Discord. You can stick to the StreamYard chat. What's your favorite database or what's your favorite database story? It can be anything. How did you come across the database for the first time? How did you use a database for the first time? Was it you covering up for a team member who couldn't get their back and running in time? We're going to be studying a streaming database called Rising Wave. Okay, I like how Susmita answered for me. Yes, I do like IoT, but I do all kinds of other stuff. I have like tons of glass work that I like to do, which I can talk about in a complete different 3 hour session. So yeah, get your stories up. Okay, you've only used MongoDB. What's the story behind it? Did you come across MongoDB because it was an MLH sponsor category? And was it fun running it? Did you have any trouble? You love Upright Cloud. That's amazing. I haven't gotten around to using Upright Cloud to its full extent. I only used it once with my Raspberry Pi, and even then, Aditya helped me a lot. So, all right. What about others? Cockroach DB learned it for implementation in my hackathon projects and category. That's awesome, Smart Mind. Welcome back to the stream, by the way. And how was it? Was it fun? Did it work? Did you all win the prize? No. That's okay. Knowing about them is a good start. Oh yeah, same here. I used SQL in school as well. I hated it then. I'm not very fond of it now either. There we go. You all are already forming teams. That is awesome. Oh, you won it 3 times? Well, then you're our Cockroach DB expert. Every time I say some pointers about the database, you can tell me if CockroachDB does it, how it does it, or how it does it differently. That is amazing, Nasarg. I have found that Firebase is fairly simple to use because of its community support, and that brings us back to the circle of how having a really wide community base can help everyone learn that technology. Wow, Roshan has used a lot of technologies. So he's used SQL, Mongo, and Postgres. Awesome, folks. That is great. I'm glad you all interacted, and let's move on. Our intuition exercise. What is a streaming database? What do you think is a streaming database? What could be different about a streaming database? Unfortunately, it isn't. Azure IoT isn't. I haven't used Azure IoT in quite a bit. I did an entire stream on it like a year and a half ago, but I haven't gotten around to using it since then. But if you all are interested, I'm happy to, create something for it. But no, that's not the question, folks. What is a streaming database? What do you think is a streaming database? I don't need the correct answers. I just need you to tell me what you think comes first to the mind, right? It does not have to be correct. You all have the best analogies. I think my favorite session was APIs when I asked you all to tell me what an API could be. And one of you all answered that an API is basically your sibling getting you water or you sending your sibling to get anything from the kitchen, which was amazing. So yeah, streaming database, what is your take on it? It does not have to be correct. It's just an intuitional exercise for you all to understand the entire thing better. What do you think is a streaming database? Hi Anuva, welcome back to the stream. Awesome! I love the answer, Alvin. A database that streams, of course. Hi Ashish, welcome back to the stream. Ashish has joined after such a long time. I haven't seen him in hackathons either. Multiple data sources that helps in processing real-time data. That is amazing, smart mind. That's basically the answer. Great job. Finally, indeed. Hi, Alvin. Welcome to the stream. Alvin and Ashish both have been quite quiet in this GHW. That is a great, great approach. DB get more towards fast writes. That's awesome. Like live stream. That's a good. I mean, to be fair, that's exactly what I thought when someone said the streaming database. I'm like, okay, so you put a movie in the database and streamed it, right? That makes sense. That is a great answer, IMSNOS. Can anyone? Nothing. We've done literally nothing. We're just getting started. We're just talking about what you think a streaming database could mean. I know, I can understand, but I'm glad you made it to this one. Sunday morning it is. I like this. I love this analogy, Nasar. Great job. That is perfect, Roshan. That's exactly what I want you all to answer. What do you think? And that's basically the answer. You already know how streaming databases work. Go ahead, put that on your resume. That is awesome, Ashish. Hi, Specback. Optimizing streaming? Yes, basically. Awesome. I love the answers you all came up with. And Nisarg was also, made up for all the creativity. So keep posting your answers. I'll just quickly start giving you an overview of how a streaming database can work. Now, there are multiple of those out there, and you can use and choose based on your final outcome, obviously. Then there's something called change data capture, something I am pretty new to and I've started reading about recently, but it's very interesting. And yeah, we'll get to it when we get to it. I'll show you some pictures also of the visualization. And I'm happy to share my slides, but there's literally nothing on them that's actually you can, refer to. I use slides more as, flashcards for me. So, but I'm happy to share them regardless. And this time I've gone with the Google recipe book theme because I love the blueberries and the vegetables that I've put on it because I get extremely hungry when I'm taking a stream. All right, encoding video. That is a pretty interesting approach. Sure, Anubhav, if you want the slides, I'll share them later. All right, real-time live stream. That is a good approach also, but it's also very conflicting in that sentence. All right, folks, what is a streaming database? The traditional definition of a streaming database, also known as a real-time database, is a database management system that is designed to handle a continuous stream of data in real time. Exactly what you all answered. It is optimized for processing and storing large volumes of data that arrive in a continuous and rapid stream. Okay, but how is it different from what happens? Like, what is different from the current approach that is there? Why did the people have to create streaming databases, and then not just the normal database? What's the normal database doing differently, which has a streaming database? What about the Twitch interface is the streaming database that's being used? What do you think? So the video, in case you all are wondering, the video that is being streamed is not part of the streaming database, in the sense that it's not being streamed through a streaming database, right? There's something called WebRTC and basically real-time connection. So that is not something that's being used here. That is something being used for the video. That is not a streaming database. But what other things on the screen that you see could be from a real-time real-time database or a streaming database? It is, they are important, but again, the video that you're seeing is not coming from a streaming database. Awesome. Chats, maybe. Chats to some extent, yes. All right, folks. So those are some great answers. But before we move on to, before I tell you what exactly on your screen is a streaming database, could be a streaming database value, why do we need streaming databases? What was different from what we were doing currently, or how are we doing things currently that people had to go out of their way and create streaming databases or real-time databases? Live polls, okay, that's a good example. But you're still not answering my question. What is different? You all are giving great answers. All right, folks, I'm going to give you the answer since none of you all are even trying to answer the question I asked. But the answer is the normal databases, right? Your video is not a streaming database. Okay? Your video that is being streamed is not a streaming database. Kind of, yes, it helps. Collaboration can be to some extent a part of a streaming database. I do not know for sure, but I can tell you based on these examples, you all can tell what might be using a streaming database and what might not be using a streaming database. That sounds correct, yes, but I will confirm in a bit. Kind of. All right, folks, since none of you all actually answered my question again, or maybe I didn't ask the question correctly, the question I'm asking is, why was there a need to create a streaming database? Well, because the original way of processing data is something called as batch processing. Can anyone guess what batch processing means? So there's something called batch processing, then there's something called real-time processing, and then there's something called micro batch processing. So can you all tell me what could be happening where? So batch processing is the older way. Then when we realized, okay, batch processing might be a little slow for our applications, we came up with real-time processing. And then to find an optimized way somewhere in the middle, we came up with micro batch processing. You heard it in the operating system class. Okay, so you do have a big idea of that it exists. Okay, good. Big data, not the one cool kids like. Okay, good answer. I'll take it. Nasar has heard it. Tables and columns. Okay, so even our real-time database has tables and columns, but the tables and columns values change. Alright, folks, I'm going to give you another minute to maybe think of the differences, right? Batch processing, processing in batches, real-time processing, processing data real-time, and then micro-batch processing. So the answer is literally in the definition. If you all can just try and just think for a minute. Okay, that was from before. Fair enough. All right, folks. I got one of my two. Basically, Piyush, that is a great answer. I like how he has streams in his username as well. Great job, Piyush. One after the other. Yes, for streaming. Your answer is absolutely, correct. The only difference is it's not for not bash processing, batch processing. Let me type it up for you all in the. There we go. Batch processing. Diamond stream. Precisely. That's one way to look at it. That's actually a good implementation of a streaming database, I'd suggest, but I'm not sure if they use it just yet. Mm, That is a great answer, Skull Crusher for life. Perfect, Kunal. Exactly. Yes, batch processing. Precisely, like backups. That's a great answer, right? So what happens in batch processing is that you take that's filters is a great answer for streaming databases, right? So what happens is batch processing is basically you do not care about the data in real time. You know there's a ton of data coming, you just store it, and then when there's downtime or when you know, okay, now I have enough data to process it all at once, you take the chunk of data, process it. What does processing really mean here though? What are we processing exactly and what's the data we're talking about? I am not sure I understand the example, but I love the attempt at creativity here. I don't think you typed this up, Anubhav. I think this is the copy pasted answer, but again, appreciate the effort. Alright, perfect. So batch processing usually happens for data that you need to basically analyze to some extent. So let's say you have user data or data like okay the user spent this much time over here on the website, then over here, and then left the website. Now, depending on your application, you don't really need to process this data immediately. Okay, for example, a clothing website, while there's I'm sure that using a lot of doing a lot of an analyzing real time, they don't need to process it immediately. They don't need to show something immediately based on that, right? So they can go back, process it in the once there's a downtime, they can process all of it in a batch, huge batch, and then either send recommendations or basically take feedback for the UI or anything on those lines, right? Then there's something called real-time data processing. Where do you need real-time data processing? For example, you see your Twitch screen, you can see the number of viewers, right, at some in the right corner of your video. That is real-time database to some extent, where it's taking data, processing it, and sending it to the front end, right? That's to some extent processing. For example, on StreamYard, I have this tiny viewer count where I can see how many people are tuning it from Twitch and YouTube. Now, this is true streaming database because let's say Twitch, it's their data, they can simply pull it and show it on the screen, right? They don't really need to process it to some extent. It's one query. But on StreamYard, there are multiple data sources, right? So it's taking multiple data sources, multiple tables, taking out the data at once, querying that data, and then making a new table, and then pushing data from that onto the front end. Make sense? Hi Yash, welcome to the stream. Yash hasn't been attending a lot of streams this time. But yeah, does that make sense, folks? So a streaming database is basically something that is one of you all said filters, which is a great word, right? But the official term for it, or rather the term that is used for it, is materialized views. What you're doing is you have tons of data coming in. Okay, the users clicking here. This is the link they're clicking. They're staying on for this long. They switch to this tab, or they switch to this product category. You have tons of those data. Based on that data, you're creating materialized views. What are materialized views? They're kind of pre-assessed queries. So you kind of know, okay, this is what the user is going to do. This is the query I need to make. So you make those queries So you pre-query the data and you create a new table. So as the data comes, the query runs and the table is created. Now, based on this new table, your real-time analytics or your front end is going to be pulling data from this. Maybe, there of course there's some latency, but the whole point of it is to, reduce as much latency, because the query is running before the data comes in, right? So the data comes in, the query runs, and the new table is basically pushing the new data. Does that make sense, folks? Okay, I see there's a lot happened in chat since I saw it. I'm glad you did. There's an entire data week coming up indeed. Bye, Yash. All right. All right, folks. Does that make sense though? Yes, what I just said? Or is it just all, you said something, it makes no sense? It could be happening, it could not be happening. Doesn't really matter. Any questions regarding the explanation I just gave? Alright, let's move on to the next slide and see how it could be a little different from a regular database. I like the priority here, for sure. I hope the nope is for no questions and that you didn't understand anything. Not for that you didn't understand anything. Alright, great. Nasarik says 100. I'm going to take that as a good sign and move on. Alright, how is this real-time database then different? I mean, we're basically working with the same tables, right? Well, the data stored in tables matching the structure of the writes, and all the computation happens on read queries. Okay. So everything in your real-time database is basically the same to SQL or your any other traditional database, but this is where it gets different, right? Like I said, you are basically pre-querying the data, right? Alright. Totally different discussion happening in chat, very distracting, but continue. So everything is being stored in the same way it should be, but in your streaming database. You remember, it's when you have a streaming database does not mean you do not have a traditional database. Ideally, you have a traditional database, but you're continuously also connecting the data to a streaming database, and the streaming database is running continuous queries. So your entire structure will be in terms of pre-queries. So the writes and all the computation work happens as soon as the data comes in, right? And then they operate on a continuous basis, right? As soon as the data comes, it goes through a filter of processing and then it gets stored in table, which is your materialized views. Does that make sense? I hope. I mean, this is as simply as I can put it, really. All right. So why is a streaming database so important? I think a really good example is StreamYard, right? It's not just processing data from one database, right? I mean, that was a simple task. You all could have written it in a script and, you could be running it continuously. The reason why materialized views become more important is because you all can connect multiple data sources and then run processing on all of them together and create a new table with much better, analytical values and better visualizations also. I'm glad it makes sense, right? So, all on the same page? Great. Let's look at what are the different ways that you can do stream processing, right? So what we're doing here basically is stream processing, okay? So what's the stream? The data that you're sending to be pre-queried, all right? Now, pre-queried is the word I use for my understanding. It is not an official term, just so we're very clear. All right, let's move on. What is SQL-based stream processing? Before we look into what's SQL-based stream processing, let's look into what all other kinds of stream processing exist. That is a great analogy, Kunal. Yes, it kind of works like RAM, except it does store it for a longer time. right? So once you pre-query it, the data stays there for a bit. It's not going to get rid of the data. So there's a new table. So the streaming database is doing a work of more like a connector and sending it to a new storage where a new table or a new traditional table has been created with the new data and new parameters. All right. Uh, Oh yeah. You're always using them in combination with a traditional database, or you're sending it to a traditional database after it. For example, right? If you all have ever used Firebase, right? Firebase RTDB is very simple, right? It creates a JSON and it keeps updating the same JSON until and unless you keep sending an entire new chunk with a new, basically new path, right? Now, even though you get new path and you can access the previous paths, it's very difficult to access it. So the ideal way to go about it is you get the data, you push it into based on the algorithm, you push it into a long-term storage if you need it, or you then basically update the same value. You don't really store that same value. So what you do after the stream processing is up to you. You can stream process and get rid of the data immediately, or you can stream process it and send it to a streaming database, or a traditional database. Make sense? Oh, it does not have to be cloud. I mean, of course, you can eventually have to deploy it on a server. You need a server to be running continuously and connected, but it does not have to be a cloud. For example, I'll show you one of the local things that I run on my computer will use Docker and it will run, but I'll obviously have to keep it running continuously, which will basically act like a server. The product we'll be using does have a cloud version, and you all can always access it. It's very simple to use, and I'll show it to you. Right? Yeah, precisely. But that's optional. What would be slow, Alvin? Pushing it into a traditional database? Well, pushing it into a traditional database is a latter thing that you're doing, right? First, you're using it. So let's say, when is the pre-querying happening? When you want something pushed to the front end, or you want to see something like clickstream analysis or Twitter API processing, right? Those are all things that you want quick input. So you first push it to the front end, and then based on whether or not you want to store it, you can have an algorithm for it or none. You either store it to be retrieved data, but remember, this is a query that's running, right? Even if you don't store it immediately, remember your entire data still exists. At any given point, you can again run it, the query on it, and get that data in that point of time. Make sense? Precisely, right? There are a lot of types of streaming databases. For example, Firebase is a JSON based streaming database, and it works in its interface is very simple, but also kind of dumb because you can't do much from the interface. You have to do a lot of it from the code. And that depends on every product, what they're trying to do, what's their end solution that they're trying to provide. All right, awesome. I love the interaction you all are giving. So perfect. All right, so what is why SQL based stream processing? So before we look into why SQL stream processing, let's look at what are the different types of stream processing. So there are three options in stream processing, right? There are low level code or APIs, which is basically you writing your own script and creating your own push pull methods, right? Then there's SQL based stream processing, which is what we're going to be looking into, right? And then there's UI based building blocks that perform transformation at higher levels of definition, which means so you send all the data to your front end, right? And the front end code decides what it wants to show. Make sense, folks? That is an amazing question, Anubhav. Right? So API is an application program interface. APIs are actually older than the internet. Right? APIs are basically used to kind of connect your front end and your back end in a very simple way. But any application, right? Any application to its, users, any program to its UI, right? All of them happen with an application program interface. Amazing, great answer. So, Anubhav, we had an entire API week a couple of months back. If you want to scroll down on Twitch or YouTube and have a look at all the amazing API streams that happened, there were coaches who, helped you create APIs from scratch. Then there were people who helped you connect with API to a lot of different front ends. You can go have a look. All right, folks. All right, so why SQL? So SQL is a great solution for streaming because it is a compromise between the other two choices, right? You're not running complete. You don't have to run everything in a script. You don't have to make the front end do all the work. You can come at a compromise where you take some of the code, some of the data, run a pre-query, and then you also let the UI do some of the filtering work, right? So you can depending on what you have, what other tech stack you have, you can consider the overall power, speed, and ease of use, and then you can extend its ability. Right, so again, you can push it more to a traditional database and run more processing on it. You can use the UI based building blocks and run some processing there and show more things there. So it's a nice compromise and a middle ground between doing completely stuff through APIs or through UI or your front end code. Yep, Nisarg's right. So Twitch, all the videos get deleted after 90 days. But on YouTube, they stay, I think, forever until and unless a coach specifically requests for it to be deleted. All right, folks, does that make sense? Is there any question here? Do y'all have any? Okay, I lost your tab. Give me 1 second. There we go. No questions. That's awesome. There we go. No questions in API and application interface with a specific function. That is amazing. Thank you so much for the answer, IMSNOS. All right, folks, let's move forward. How do you choose a streaming database? So this is a tad bit of an advanced thing for me to be telling you all because there are a lot of words that you all are not aware of, which is okay. If you all don't know the words, that's okay. I'll go with them if you ask me to. Otherwise, things are fairly intuitive, right? Thank you. I'm SNR. Super helpful. Everyone super helpful in the chat, right? Alright, folks. So a lot of words. Let's look at all the words. We already know what's a streaming SQL. We'll look at a Kafka stream in just a minute. Data source. We've already looked at data sources. Remember, StreamYard having data from Twitch and YouTube are data sources. You're mixing the data sources. So that is a huge consideration for your a streaming database. Can it connect data? How many data sources can it connect? How easily can you connect data sources? Is there much more latency based on the kind of data source? And these are the things that you need to consider when you're choosing a data streaming database, right? Then there's scalability. Now, as hackers and as students, this is not something you all would worry about. But it's like the whole IoT thing, right? That I do. It is always good to know and have an approach that is taking into consideration the defaults, right? Then there's integration. So after processing the data, how easy it is to integrate it with other, front ends or traditional syncs, right? It shouldn't be just one way. Then you have to actually work much harder to connect it to the final endpoint, right? Performance. How would performance be different? It depends. The performance will depend on a lot of things, right? For example, we've spoken about the very basic thing that a streaming database is supposed to do. We don't really know what's actually happening, or we haven't really seen an actual example of it happening, right? So performance will be based on what exactly are you trying to process. Are you trying to process multiple tables at the same time? Are you trying to process and make charts out of a single line of data very quickly? And what is the extent to which you're pushing it? So all of these things come under performance. Another pretty good thing that comes under performance is the capture data change data capture, right? We'll look into it a little bit more in a bit, right? Security. Now, honestly, I can't talk about much of the security from a streaming database point of view, but for the most part, security of normal backend, the normal, backend hygiene of security falls into place here, right? And ease of use, of course, right? You do not want to work hard just to get the basics up and running too much, because then that kind of spoils the point of you having to use a streaming database. You might just, make your own tech stack. I have no clue what this is supposed to mean, but I appreciate the comment in IoT nonetheless. All right. Okay. So let's look at a couple of sentences that I've put. These are some of the important things that you want to keep in mind when you're selecting your streaming database. So the KPI for streaming data platforms are event rate. So what are the things that, so when I say performance, right? So that's event rate. So event rate times event size, which is what I said, right? How big of a data you're trying to process versus the time that you're getting, right? Latency, how fast is it getting the data and sending the data after processing? And of course, the processing time. Reliability, how often does it, have an error? What's the error margin? And the number of topics for, like I said, right? How many data sources can it do? How quickly, right? Now, there might be a database that can let you connect 100 data sources, but then the latency is so low or high, I'm sorry, my data latency is so high that it's really useless. You might just, process it in a traditional database and batch process it. Yes, delay is high. Right? And then, so the specific database that we're talking about, Rising Wave, dynamically partitions data into each compute nodes using a consistent hashing algorithm. There's this very nice name for this algorithm that I'll give you all later. It's an entire, it's specifically designed for streaming. And these compute nodes collaborate by computing their unique portion of the data, then exchanging output with each other. Right? So this is basically, again, part of performance, right? This is how it basically does a dynamic data integration with a lot of other processing. Make sense, folks? All right, so what's a Kafka stream? Does anyone, because other stuff on this slide we have covered more or less. If you all want me to dive into any of this a little more, scalability, integration, performance. So this open source, this node algorithm is more towards scalability sides than it is towards integration. All right, and yeah, what do you think is a Kafka stream? Anyone want to take a wild guess at what's a Kafka stream? Same question. What is it? I like how you all have heard random words in your classes and you're like, yeah, now tell me what it is. Can I repeat what? The algorithm for scalability? So, Apache Kafka. Yes, Apache Kafka. That's what I'm asking about. What is a Kafka stream? What is an Apache Kafka stream? It is basically that. So what's happening in so for example, if you want to use Rising Wave, you'll end up using a Kafka stream. What Kafka does is basically it's kind of a connector. It will create that stream of data. So as the data comes, it will send it to your streaming database, and hence the processing will take place. Because being able to send data continuously in a way that you don't lose data is also a very important part of the system. And it does have pretty good writing speed. Kafka is really known for it. Writing, more than writing, it's there for sending, right? It will pick up precise data and it will send precise data. So why do you need a Kafka stream? For example, if you have a streaming database that is supposed to process, say, 3 out of the 20 parameters that you have, you'll use a Kafka stream to only send that much data to the streaming database. So it kind of fastens the entire process. You can send all the data and your database, your streaming database is also finally going to query the data before it processes it. But when you send just the data it needs, it makes the entire process faster, right? Oh, was it? That is a very interesting fact. I had no clue it was developed at LinkedIn. That is interesting. All right, folks. So now we're going to start looking into what I've been talking about over and over again. So I'm going to take a quick breather here. I'm going to give you all 5 minutes. You all can go to the Rising Wave cloud. Let me send you all a link to that. Rising Wave. There we go. So I'm going to send you a link to this. Now it might not open for all of you all, and if it does, it will probably ask you to send a beta request. Go ahead, do that. If any one of you receives the data access immediately, you can follow along. If not, you can follow it later. There's no rush. It's a very simple thing. I'm basically going to be clicking around on examples. This is amazing. There's an Apache incubator. This is so cool. Even though I can see it's from Wikipedia, that's cool. I appreciate the effort, Anuvab. Alright, folks. I'm going to take a 5-minute breather. You all are welcome to, quickly stretch your legs and come back and sit. simple session still, like maybe 30, 40 more minutes of, us just going through different examples, me showing you how it runs locally, how can you run it locally. All right, folks. Awesome. I will see you in 5 minutes. Alright, folks, how did you all try signing up? I can see you all did try to sign up. Yeah, no, I know. I think they have it in the beta phase. Bye, Alvin. So I know for a fact they have it in the beta phase right now, so they're not allowing sign up, but I know that y'all can request sign-ups. So let me quickly see if I can find the page to them letting you get sign-ups. So Rising Wave Cloud. Hmm. Did it let you all sign up by any chance? There you go. This is the sign up. You can just put your school name, your college name. Let me know if this link works for you all. Oh, you need an invite code? Is that what it's asking you? Give me 1 second. Um, Let me check. Okay, let me. Okay, let me go. Try just googling for that. I'm just gonna go to an incognito. Oh, done. You did not require invite code. Awesome, perfect. So y'all can sign up immediately. Y'all don't need an access code, right? That's perfect. So y'all, if y'all are signing up, then let me know. I'll give y'all another minute to sign up, folks. This is the link that's working. Yes, Anubhav? Awesome. Nisarg signed up as well. That's great. So I'm gonna give you all another minute to sign up then, and then I'll take you through it. So I'm gonna quickly go over some of the architectural stuff that is here. So let me show you all. Okay, so this is what Rising Wave is basically doing, right? You have computer nodes, you have compute nodes, and then you have persistent storage. And then the one on the left is your Apache Flink, which kind of does the similar thing, but it uses the persistent storage as a checkpoint. In Rising Wave, your persistent storage is where they're kind of doing all the computation. Well, you all can put your college names for company name. All right, folks. Let me now quickly go to the next. This is the architecture of your Rising Wave database. So you have your computer nodes, you have the object storage, then you have the meta store and the meta server where all the syncs get connected, and then you have your serving layer, which is your front end node, and then you have your processing node, your compute node. Make sense? So you have your sources. This it first goes into the front end node, then it goes into the compute node, and then it goes into the compactor node. If you want to create object storage, if you do not want to create object storage, you can directly send it to the meta server and then sync it. The meta store and the meta server is what is basically is basically the reason why you're processing it real time, right? Alright, folks, give me a heads up once you all are done signing up. I know Nisarg and Anubhav are done signing up. I think Kunal is still signing up, and I don't see other people replying. In case you all are, give me a heads up. I will wait for you. Alright. I'm going to stop sharing this. I'm going to share my Rising Wave Cloud now. So, here we go. Kunal's done as well for signing up for the database, and here we go. This is how your dashboard is going to look like once you sign into Rising Wave. A couple of things we'll go over. That's why I've shared the entire video. So what's Rising Wave Cloud? Let's have a look at what a Rising Wave Cloud is, right? It basically simplifies and streamlines data processing for modern data workflows, right? It is a fully managed and scalable platform. So, when we are talking about it being easy to use, this is their Rising Wave telling you that, okay, we are trying to make it easy to use. However, they do have a open source Rising Wave database that you all can also use uh, using the GitHub repo, right? So they call it intuitive. I have my bias because I'm not a backend person, and I took a while to figure my way out around here. And then you can just basically see that this is all you can do. You can basically do a lot of visualization and a lot more by just running different queries and things like that. All right. So I want to go back. All right. Now I'm going to go here, and they have a nice user guide to get started in 5 simple steps, which won't open for me. So I'm just going to reload this page. Quick start. All right, so let's look at quick start. So what I usually do and what I am going to do for you all is I'm going to show you the playground. Basically can make a cluster and just play around with all the examples that they have. But we're going to go through quick start once. All right. We'll also try and create, you can see this is how simple the playground is, but we're going to go ahead and create a cluster, right? So free plan. So the reason you were getting an invite code is because of this, right? They also have a bring your own cloud coming soon where you can basically connect your own server, right? So I'll go for Google Cloud. Just no reason really, just randomly. Cluster name, I'm gonna go for GHW season launch. GHW season launch. Alright, so that is it. I'm gonna create the cluster. Alright, Anubhav is done. Also great. So there we go. So great. Awesome. So my cluster has been created. Now what I can do is I can go into the query console. It's still creating, so I'm gonna wait for it to finish getting created. Now I can add database users. I'll have to create a database user no matter what I'm doing. So I'm gonna create a database user. I'm gonna add a username that is gonna be Ritvik. This is the super user. No matter whether or not you own the DB, you're gonna have to create a user. Alright. I'm gonna give a simple password for the time being. There we go. Created. Clusters aren't available because it's still being created. Alright, so we're going to wait for the cluster to get created. I'm just going to remove this. By the time so a super user is basically a user which has all the rights to the database. It can write to the database, it can delete clusters, it can create not clusters because you're creating a cluster user, but basically in that cluster it can decide what database it's connected to, basically all the rights, right? Any changes that can be made, the super user can do. You're not able to sign up, Shakti. What's happening? What's the error that you're getting? Do you want me to share the link again? Do you have access to this link? There you go. I think this link apparently works better. Alright, folks, my cluster is still being created. So until my cluster gets created, I'm going to go with there we go. It's running now. Perfect. I'm going to create a database user now. So it's going to be and I'm going to make a simple password. There we go. So user created, not don't want to save. And now you can create more users and give them different kinds of rights based on what you want to do, right? Now you can see these are the stats. I do not have currently any materialized views, so I can connect. But what I'm going to do instead is I'm going to use enter console, right? This makes my life much easier. And now I'm going to have to basically enter the. Alright, so now I've entered my console. I'm going to go back to my quick start and see what they're asking me to do, right? We've created a cluster. We can manage clusters, which is great. We've done this. Let's do manage clusters. We know manage clusters. Alright, we've followed everything in the user guide, so great. But what's the fun part is that they already have a lot of examples for us stored. Take your time, Shakti. I'll repeat it whenever you want. Alright. So now they have client libraries, they have a lot of stuff over here. We'll go over it one by one. But what we do want to do over here is first we have the playground that you all can play around later, and they already have these notebooks, okay, that they've created that you can go through, right? But we also have our console. It didn't log me in. Thanks. All right. So this you can always run jobs here, but instead what you can also do is you can run sample queries. So they already have a lot of data here for you. They have created entire tutorials for you. You can go over it. So right, you can see what's happening here. First, they're creating a source called Twitter with so and so with these parameters, with these, tables and rows. Then you have, I don't know what's happening. Right? So then you have a connector. Again, see they're using a Kafka connector to make sure that the stream data reaches in time, and they're sending the data as JSON. All right, perfect. So we have our table of data that we want. It's being connected using Kafka. Then what we're doing is we're creating materialized views, which is basically our filter views, right? So what we're doing is we're creating a regex expression matching what we want. So let's say it's a hashtag over here, and it will find the text of the tweet. I really don't understand why it's doing this. Okay, great. So, it's going to find the text in the tweet that matches the regex expression, and then it will extract all the hashtags from them and store it in an array, right? And then it will separate each array into a separate row. Okay, there we go. Then it's connect the hashtag occurrences, and then it's also creating a tumbling time window function, and then generating rows for that as well, right? Finally, it's querying the results, and that's the final thing that you want, and then it will sync it into the integration that you want. So season 1. Okay, so what it's doing finally, it's doing the final query after processing the data and creating a new table of the data that you want. It's creating a new table. From that table, it's querying the final thing that you want, and then syncing that only that part to whatever you either want to store or whatever you want to push into the front end. Over here again, you're using a Kafka connector and sending a stream of data to wherever you want to sync it or use it. You do not need the code. Over here, if you go into the console, let me show it to you again. Let's go over here totally from scratch, right? So you have a cluster running. Click on the cluster. Click on your cluster again. Over here, you should be able to go into your console. So let me find the console. Materialized views. When you go to materialized views, it will ask you if you want to go into the console. So you can go into the console. And once you go into this console, you can have sample queries here. And I was looking at fast Twitter analysis. Okay. And then this is the thing. Now I can always run this. And it will show you how fast it executed. So you can see the latency that's happening here. You do not need the code, Anubhav. You can literally just go on there and run a sample query. Let's look at another example while we're at it. Did this example make sense though, folks? You basically first created the table that you want the stream to go into. So you created a table with these things. This is what you're expecting from the stream. From this stream, then you're connecting the actual stream of data, and then you're finally putting it in JSON format. Then you're creating a materialized view, which is basically a new table, a processed data table, and you're processing the data and creating a new table called hot hashtags. You're finally creating a query to what for the table that will finally be pushed into the content or the sink, whichever it is. And again, your connector for the stream going into your sink is also Kafka. Everyone same page. I do not see any questions in the chat or any basically any comments. I'm wondering if you all are following along. Oh, this is not my channel. This is MLH's channel. I'm one of the coaches here. And yeah, we basically do a lot of technical live streams and we run a lot of hackathons. You can check out the website. There you go. I think this will help you. Gian. All done, Roshan. Awesome. Is it fun? It's simple, right? Right now it looks simple. How you finally use and push the data is a different problem altogether, but we're not solving that. We're just trying to understand the working of a streaming database, right? So let's look at another example here. Oh my god, it needs to stop asking me for a password. Okay. No. So let's look at another sample query. Let's look at live stream metric analysis. And let's look at what's happening here. We're again doing basically the same thing, right? We have created this table. This is the data that we're expecting from the Kafka connector, right? This is the basically the server from which we're expecting it. And then we're expecting the raw format to be JSON. All right, we're then creating a materialized view. Let's see what the materialized view here is being created for. Oh my god. Alright, so what we're doing is we're trying to sum up the total freeze duration and the video total freeze duration. Okay, so we're summing up the video total freeze duration and we're saving it into this variable, or rather this parameter. Then we're averaging out the lost, I'm not sure what PPS is here, packets per second. So that's what's PPS. And then what's RTT? Round trip time. That's the RTT value that's being stored. So basically trying to measure the performance of a video, right? And we're getting a lot of data, right? We're getting tons of data, but we're only trying to process this much data, right? We're doing this and then we're creating another tumbling time window function and storing it into the live video QS 10 minutes. All right. Then the final query is on that from that table that we made here, right? We created a new table with the processed data, processing all the data we got. And from this final data, we're querying and we're then sending it over our connector to the sink, which is basically your final output point. Now it can be a traditional database or it can be a front end point. Make sense, folks? Any questions here? Anything that does not make sense? Again, we're connecting it to the connector and sending it across, and we're also giving it its primary key and we're sending the format of it. Well, I'm so glad to know that this will help you. We have a lot of streams. So this is live streaming and we have all these streams recorded and stored as well. So you can watch them anytime you want. All right, what about the other folks? Are we all on the same page? Great. Let's look at what the last example over here. Same thing again, and then I'll show you some of the local implementation on how it works if you're running it locally. Awesome. Oh my god, this is getting a little annoying. Alright, let's look at sample queries, and this is the last one. So I'm going to give you all a minute to go over this. Right, this is slightly more, you can see it's more layered, but that's the fun of it. Alright, so I'm going to give you all exactly, so it is 11:49 in my clock. I'm going to give you all until 11:53 for you all to tell me what's happening here. Alright, so take your time, go through the example. If you don't have the example, let me know. I'm happy to push the code onto StreamYard or Discord, whichever works better for you. Alright? So you all have exactly 3 minutes or 4 minutes to tell me what you understand. How's it going? Does anyone have understand what's happening different in this example? Oh my god. Anyone want to explain to me what's different in this? Gian, I can tell you how I started mine and where I'm at, but I don't think I'm qualified to tell you anything more about your journey. However, we do have some other coaches who have a CS background and will be able to give you much better advice on these things. Let me see. Vay had a session yesterday, and if I'll just check if Vay has any other sessions this GHW, I think he'll be a great person to give you advice on that. Let me check. Uh, Day 7. So no, Way does not have a session, but I suggest you join any of the other CS based sessions. I am doing a CS based session, but I'm not a CS person, to get better advice on how to go about it. But the usual advice that you get is, learn a little bit of DSA and start with a little bit of lead code and HackerRank. Different people have different ways of learning. Hackathons are always a great way. I prefer hackathons to learn it. I don't see anyone answering my question about what's happening differently in the final example. Are you all looking at it? Do you all need another minute to look at it? Or do you want me to explain it? Alright, folks, since I don't see any answers coming my way, or if I don't know if it's my internet that's not letting the comments come through. Yeah, even I randomly lost my connection in for a second, but that's okay. Oh, sure. I did not explain anything till now. All I have done is I've asked you all to go through the last. Did you miss the earlier expressions as well, explanations as well, Nasar? In that case, I'd suggest, okay, what's happening in all of these, right? So we started with this explanation where I said, okay, what's happening here is we're first creating a source, then we're adding data to the source that we're creating with the connector Kafka, and we're expecting the JSON format to be sent to us. Then what we're doing is we're creating a materialized view, which is basically creating a table by processing the data, and you were using a window tumbling time window function to create a time framed based data table, right? Then what's happening is we're querying the new table that we just created, okay, based on what we just need in the front end or the sink, whichever that might be. And then we're sending the data to the sink, which could be Grafana, which could be another dashboard, which could be your front end, using Kafka Stream again. All right. And we're also specifying the primary key. The same thing we're doing for the live stream metrics analysis, where we have a couple of more things that we're doing, where we're taking a huge time frame. Then for the time frame, we're basically summing up a particular parameter and averaging out another parameter to create the new table of processed data. And then based on that data, we're again creating our final query and sending that final parameters and those only that much data uh, to our final point, which is your connected data. So over here, we're making multiple parameters that we're processing, but there's something extra happening in the clickstream analysis that is different from the earlier ones. And I want you all to point out that to me. What's different over here? No worries, Jan. Did you all understand my question? In case you all haven't, let me just quickly explain it to you anyway. So what's happening different here is basically we're creating a middle point in the processing, and then we're using that middle point in the processed table to create our final table, right? So we're creating like basically phases of it, and then we're sending different from, but our final query is from those different phase tables, and that's what we're sending to our final connector. Okay. Makes sense, folks, what's happening differently here. But what you do understand from that is that basically makes you understand the extent of the power of a streaming database, right? So you didn't just take a lot of data, you ingested a lot of data, then you created multiple versions and phases of filtered data, and then from that data you created the final querying data, right, from the thread view count and the view count, and then you're sending that across to your endpoint. Right, so that's the base idea. So you have a connector, you get the data, your data, you can see all the time we've used a Kafka stream to connect it, right? Kafka connector, and then we're basically creating a new table, basically processing the data that we've got and creating the new data that we want, whatever it is. For example, in the video one, we averaged and summed multiple data points to create a new table for per 10-minute time frame, right? And that time frame now gets pushed into our final query, and that query is finally sent to the sink, which is the endpoint, which can be anything: Grafana, Prometheus, your front end, whatever that may be, right? Makes sense, folks? All on the same page? All right, folks. Now, I mean, this is a beautiful documentation that they have up in their GitHub, where you can also contribute. So I'd suggest you go over it if you can. Now let's look at the Rising Wave database. Okay, this is the structure of the Rising Wave database. We just looked at cloud and we saw how cloud works, and now you know how simple it is. So the Rising Wave database can be tried on the playground, but we won't be trying any of that. I'm just going to close everything for the time being, which we do not need. Okay, so let's look at Rising Wave database. And If you all know what's Flink, great. If not, that's okay. You do not need to, concern yourself with that right now. But let's look at quick start, and let's look at run database, right? So this is the local way of running it, and then there is a Docker based running it. I'm just trying to search for that one because Docker based is much easier to run. There we go, Docker. So Docker, if you want to run it on Docker, you can just run this command and it will start running. Okay, if you have Docker installed, that's great. If not, you can always go down this route. This is the route that I went, and I like going down this route. But again, so whoever asked me, I think Roshan asked me, so you can connect it to this, like you have already, libraries set up to connect it very easily. All right, but this is what we're going to be following, the Docker Compose. Okay, and if you all are following along and you have Docker installed, that's great. If not, you all can just start installing Docker and continue it at any given point. Let me share my Docker screen with you all, and then we'll finally come back to this window itself. Oh yeah. It's a very interesting and complicated topic, and you're not complicated but complex. Again, even I'm pretty new to it. I'm just starting to read more and try it more. And yeah, I mean, I wouldn't dare to do live coding with this just yet because I'm not that sure about where I could go wrong. So, for example, right, Arvin, I've been doing it for so long, and yet we made that mistake on stream. So I want to be very sure before I run you all through an actual hands-on thing. But soon, maybe maybe by data engineering week, we'll get there, right? All right, so I'm going to stop sharing my screen and present my Docker screen, right? So Docker window, there we go. So you can see I've tried two different versions. This is the tutorial that I just showed you. This is literally running it, and these are the ports that have been deployed. So I'm going to click on the port, and I'll share the screen with you about how the port comes up. So share tab. Okay, so this is the Docker screen, all right, and you can see these are the ports that are running on it, all right, and this is the latest image that is running for Rising Wave Labs that I've taken from the GitHub that I just showed, right? So let me show you how the port turns up finally. So I'm going to go back, present, share screen, window, and this is where the port looks like. So when you go to 5691 port, this is the entire thing. And from here, you can basically, see your databases, materialized view, index, syncs, graphs. You can also do batch tasks along with stream processing. So let's say there's a lot of data you want to batch process, even though you can stream process for the sake of optimization, cost, and scalability, you can do that. Right, and then there's settings here where you can connect it to HTTP API, Grafana API, Prometheus API, and that's how simple it is, right? All right, folks, we're almost done. Let me okay, I just realized I never shared my screen, so this is what I was showing you all. So this is our front end running and this is our compute running. Remember, there were two ports, right? So this is our 568 port that you can see, 5691 port right here. And you can see the CPU usage, memory usage once you start using it. Right now, I'm not really using it because I have nothing connected. So, but you can always see what all. Thank you, Roshan. I always do this once in my stream, right? All right, folks. So basically, tables, materialized views, index, internal tables, sync. So this is all that you can do with Rising Wave, right? Then you have graph, fragments. You can basically, for streaming your sync data, you can do this much. You can send more, process more data in the cloud and then send it for the streaming. I think one of the Rising Wave folks have done a GraphQL based stream processing, which is very cool. Then you can also do batch tasks, right? This is what I was talking about. Let's say you're using the streaming database, but for the optimization sakes or cost sakes or scalability sakes, you still want to do a lot of processing in batch because it makes more sense. You can do that as well. Then you have basically you can explain stuff here, what's happening in the thing. For debugging, you have basically where what data went to see if there's some error happening, and then there's settings where you can connect Grafana API, Prometheus API. That's how simple it is to connect it to whatever you want to connect. Make sense, folks? I mean, I would love to show you this at some point, but I'm not very comfortable with it myself just yet. But by next GHW, we should be able to do a hands-on pretty well. All right, I did have another thing to show you. Right, we do want to just quickly go over what's change data capture. So let me quickly share my screen again, and maybe also open the window that I just closed. History, file tabs. All right, so can you all guess what change data capture is? What could I possibly be meaning by change data capture? Welcome back, Ashish. What could I possibly mean by change data capture? Just take a guess what we usually do, just what's off the top of your head. Change the data which is being processed by streaming. That's a good answer. I'll give you that. That's a really good answer. That is a really good example, Roshan. Yes, basically what we did in MQTT. Every time the data changed, we sent out an MQTT signal. That's a great way to put it. Metadata, not really. No. We're talking about our original data itself. So let's look at very basic definition of what is change data capture, right? So CDC is commonly used for data synchronization between different data sources, right? So, for example, if you know that there needs to be some. So the concept of primary key and foreign key. Primary key is the key that is unique to every table. Foreign key can be a key which is common to another table, and you can associate those two tables using that foreign key, right? So you're using basically CDC to synchronize the on-premises data to the cloud if the organization has multiple databases to be kept in sync, right? So it can continuously capture and propagate changes between them, and that can be used for database replication across different environments such as production to staging environment. Now, this is one example. Another example for data syncing can be your YouTube and Twitch streams, right? At any given point, StreamYard wants me to show that specific time frames users. Now, it's not a very good example because there are multiple other ways to make sure that happens, but there are two different databases with two different time frames, and to keep them in sync, you can use your CDC. So every time there's a change in one table, it will try and basically capture that change and change across any table that has the similar syncing or that has similar parameters that need to be kept in sync. Fair enough, folks? Simple. Let me show you a couple of nice visualizations to help you understand this better, right? So, okay, let me share my screen. And share screen window, and these are the visualizations we're going to look at. So this is the link I'm going to be sending you where I studied CDC in the first place. Bobal writes some amazing articles on streaming databases, and yeah, you should definitely check out his articles. I'll be sending it to you in just a second. Let me just quickly send this to you in the chat so you all can go over it. But basically, you all can see what's happening, right? This is source database. Then, before any other processing, you put the CDC in place so that if there's thing that happens, there's a change that happens, your CDC will basically update anything that needs to be updated. And from that, your transaction logs will also be updated, right? So let's look at a proper example. All right. So you have client one, client two, system record of database. You do a CDC and you append another database, and your all your databases get updated. So your search index and data warehouse. Now, even though they're two different databases that need to be in sync, they're not holding the same data. They're associated data, which is why the foreign key concept is kind of important. Makes sense? So let's say you have a user database, something in that database changes. CDC is going to update all the databases that are affected by that to make sure they're all in sync with the current change. Makes sense? So users, let's say a user changes, you have a user database and you have users favorite colors databases, and then you have, users age. Let's say over here the client's color changes, both the databases will be affected by that. Make sense? Because they're both foreign keys right there. All right, let me see. That's pretty much it. That's the last example right there. Let me go back to my PPT, share screen, see. There we go. Does that make sense, folks, how CDC works? So why do you want to consider CDC when you're choosing a database, a streaming database? Is especially because when you have multiple, so let's say you have a hospital, right? Different departments will require different kinds of data from a patient. Ideally, all of it, but let's say one department only needs the pathology part, the other only needs the personal details, like the administration, right? So a CDC will make sure if any point changes, all of the CDC, all of the databases are in sync with the final time that the database was updated. All right. And yeah, CDC is fairly important, and it's so Rising Wave has an automatic CDC inbuilt into its code base. Yeah, that's all you needed to know anyway, right? We're getting started. This is streaming databases 101. You're not supposed to be experts, but you're supposed to appreciate the concept. Right, folks? Awesome. So that's it. That's all I'm going to be covering today. We're not going to be doing any more hands-on. If you all did get the cluster up and running in the cloud, though, I'd request you all to play around with it, right? Remove a piece of data, increase the window time frame, see what happens, see the latency points changing. You can keep running it. And yeah, I don't expect you all to do much more than that. It is not very simple to get it connected, but I will send you a couple of tutorials. I would have ideally wanted, I really did want you all to follow along with me, but there were a couple of bugs when I tried it on different systems that I couldn't debug. So it works on one system, that's it. If you all get the same bugs as other systems, I wouldn't have been able to help you all out. But if you all want to, this is a really great way to get started with a first hands-on streaming database project. And if you all complete the project, let me know. I'm happy to, give you all a shout out. All right, folks, that's it from me. You all can always stay in touch with me on any of my social media platforms. And I will see you tomorrow morning with a similar, presentation of a 101 topic on observability. Observability is very intricate and again, pretty new to it, but we will try to do a simple hands-on project because it is fairly easy to clone and run because there's not a lot of installation that is required. But we'll have fun nonetheless. We're going to be looking at a lot of new terms like we did today. And we might talk about a little bit about streaming databases tomorrow as well and how it might help observability in a system. All right, folks, I will see you all right. Oh, I do have a stream today evening with Zain. I'll see you all actually tonight and then tomorrow morning. All right, folks, bye bye. Have a great Sunday.